AI agents have taken over software development, and talking to a computer is nothing new anymore. Looking at the future here is how can we connect and interact with agents in a more advanced way, and not just us as users interacting with a single model, but us as users interacting maybe with our own personal agents. So here's just a concept artwork, and maybe some of you are joining from startups that are building this, but I really see a future where we have agents communicating to each other, companies offering services through agents, and potentially being available in some sort of an agent marketplace, an agent store. And just think about it like, you might have a personal agent that you then can connect to those other agents. So this is really kind of the next big inflection point in tech, where we're moving from those web services that we developed over the last decade into now thinking about how can we develop those agentic services.
There's so many tools, and one of the things I do is I look for all the tools in the landscape of AI native dev software development tools. I now found like 330 tools, and every week I discover more. So it's really a fun kind of exercise to be in. It's been amazing how technology has actually expanded, and a lot of people still talk about the large language model, which is great. But RAG came into place, functions, we would call that now MCP, that became an agent with some memory. And so there's a whole journey going from one agent, multiple agents, and sharing their knowledge.
Building AI agents, it's very, very fun. It's like magical. It's like giving the system the tools to think and act, and watching to do something useful. It's like building your own mini copilot or assistant. But also it is very, very hard. There is a saying that I saw several months ago, like someone told this or said this: if you think we are close to AGI, try building an agent. You quickly discover the complexity, which is very complex. I don't think it's straightforward to create an AI agent. But here's the thing, don't give up. If you are starting with the AI agents, start by listing the tools and knowledge that your agent needs, diagram the agent flow, try to understand the journey from inputs to outputs, develop each step iteratively, test early and often. Don't be afraid of hand-coded fallbacks when needed, and don't overcommit to a single tool or pattern. Flexibility in this case is very key. Also start with one agent. Don't go crazy and start building several agents at first.
51% of enterprises now use agents in production. That's what we're also seeing in Crew AI. So a lot of enterprises are now moving into production. And also there's been a big shift from just experimental to business critical deployments. So for example, last year it was mostly POCs. Does this actually work? But now we're seeing business use cases being deployed to production that actually help companies with ROI. Consequently, also with the improvement in models, we've seen 280x kind of cost reduction in inference, and this is from 2022. So that essentially just means better models, better agents. That's how it translates to, because the models are the brains of the agents, if you want to think about it that way. So if the models get better and cost goes down, then you get to spin up more agents to do more long-running tasks that actually agents are kind of tuned towards a lot. Another thing we're seeing is mid-sized companies are leading in adoption more than big companies in a sense.
But what if I just want to build it really easily in 5 minutes, low code? So I can go in and say, yeah, I'm going to build a shipping agent, and I give it the goal that's going to monitor all my shipping. And if they don't happen in a certain time, go to all the other vendors that are out there, FedEx, DHL, US Postal Service, look at what DCs, what distribution centers have the product, what is its weight and size, how am I going to ship? How do I then look at where I'm shipping it to, get prices and timelines, commits from all those different vendors, bring that in, make a choice of the right vendor, and then update the system and update my customer. Not so straightforward in code to cover that entire surface area, but quite easy with an agent. So I'm going to create my shipping agent with its overall goal. And then I'm able to go in and give it the tasks. These are the steps and the reasoning. And to each of these, I can give it context and more information. AI's made recommendations, but I can change these, edit them, go back in, create new steps. And then I want to give them tools. Tools are where it gets the data. That is the fuel that increases the potential energy of the agent. So I want to be able to drag and drop from APIs, build new prompts, pull from integrations, pull from MCP servers.
What is MCP? Now, let's start very friendly, very simple, very easy. It's an open protocol to standardize connections between LLMs and context, whatever context looks like in this scenario, right? So we're not talking about resources, prompts, or tools, or sampling. We're not talking about anything specific. We're saying something that hooks up LLM to context. Context can be a tool the LLM needs to perform a task. Context can be a database, it can be a PDF file, it can be whatever it needs. So the idea is let's standardize the way that we hook up LLMs to context. Now, in a very superficial sense, MCP is what has the potential to make AI super useful for building real apps. And lucky for us, folks, after watching Antje amazing presentation on agents, it's super useful for building agents as well.
What should I measure? First off, measure what matters to you. If you're running on a tight budget, tokens might become a little bit more important than if you're not running on a tight budget and you've got those beautiful, beautiful big enterprise contracts. Maybe you care about safety or PII, personal identifying information. If you're someone who works in a regulated industry like finance, like our finance example, I probably want to err on the side of I would rather have my agent be a little more close to heart and guarded in what it does versus, hey, oh my goodness, this is the most amazing thing that's happening, or in telling the world everything. That's really going to depend on those end use cases. Then you're going to want to establish those baseline. So even before putting something into production, and you'd be surprised, I've seen agents go to production without kind of walking through it a few times. Understand what your agent will do right out of the box. And better yet, if you're going to change your model, understand what your agent does out of the box with those models as well. How can you evaluate your kind of current performance before even making those changes? Track trends over time. So what looks like over a month, what looks like over a year, and get people to test your application that did not build your application. I cannot reiterate that enough. We would, especially those of us who build, we know the tools that are kind of our agent has access to. We know the resources. We know how the models tend to perform, but we want to see how our model does over a longer period of time.
Why should we even focus on, inference performance and, how does this relate to agents? So as all of the talks have discussed since the beginning of the day here, since like Antje's keynote, is these like LLMs are extremely, extremely critical to the reasoning and, to the whole agent workflow. So making that one piece of the stack super fast will give us faster time to response, will get us to the point where we can do longer reasoning chains, we can think longer, we'll have faster like end user experience will be much faster, so the end users become happier. We can also, save costs, right? These like GPUs cost quite a bit of money. If we can serve more users with that same hardware and more use cases with the exact same hardware, this is hugely beneficial.